This is group 6 and we chose EM radiation. The reason that we chose it is because EM radiation is the basis for understanding astronomy. Some of our main points here are talking about gamma, X-ray, UV, visible, infrared, micro, and radio waves. From gamma waves, it has the highest frequency all the way down to radio waves, which is the lowest frequency.
There's a few key terms that we need to know. Frequency is how fast the wave is, how many waves are moving in a given time period, and it increases with more energy. So this is less energy, this is greater energy. The amplitude of a wave is from the center line to the peak, which depends on what type of wave it is. And the wavelength is from peak to peak, or from trough to trough, which also it decreases with energy because the waves move closer together.
According to sciencelearn.org, we found that some of these examples are used in astronomy. So for radio waves, you find like the cool gases, and then micro is background radiation. Then infrared is the cool dust and gas. Visible is outside of the stars. UV is very hot stars, and leftovers is supernovas. X-rays are, again, remains of supernovas and hot gases in galaxy clusters. Gamma waves are material around the black hole. And then, according to nasa.gov, some today radiation you can see in our everyday lives are radio is like the radio stations, so those are like 98.5 the beat, you know, and then the microwaves are how you heat your food up in a microwave. Infrared, night vision goggles. Visible, anything you can see with the visible eye, so like light bulbs. UV is the sun, and then X-ray is doctor X-rays or dental X-rays to view your teeth, and then gamma waves are doctors use gamma rays.
At the less intensive end of the electromagnetic spectrum, we can observe that there are longer wavelengths in the radio, micro, infrared, generally types of waves. So they have a longer wavelength, meaning that the distance from the troves and the peaks are much longer than the other end. They also have a lower frequency, which means they can go up to 100 kilometers. They're very weak, however.
The reason these waves have shorter wavelengths is because as these waves become charged, they're moving a lot faster. That therefore meaning, because they're moving a lot faster, a lot more waves can reach by, so you're receiving waves that are much less in wavelength compared to over here at radio waves. It begins to slow down